Let us solve this problem. The rocket starts from rest at the same elevation. Rocket A accelerates vertically at 20 meter per second square for 12 seconds, then maintains a constant speed. Then rocket B accelerates at 15 meter per second squared until reaching a constant speed of 150 meter per second. Construct the ATVT and ST graph for each rocket. What is the distance between the rocket when t is equals to 20? So, before we analyze this, we need to break out the given for the two rockets. Let us first construct the graphs for rocket A. There, our rocket A. So it's given that rocket A has an acceleration of equal to 20 meter per second squared. At time is equals to 0 since it starts from rest, and then 2 time is equals to 12 seconds, and then a constant speed. When we say constant speed, the acceleration will be 0. Therefore, your acceleration is 0 from t is equals to 12, since for 12 seconds is the acceleration, and then it maintains a constant speed until the time 20. So from this given data, we can immediately construct an AT graph. So acceleration in time. So its acceleration first is constant for 12 seconds, which is 20. This is 20 per meter per second squared, and then 10 for seconds. You have 12 seconds here, and then 0 when it reaches 20 seconds. This is already our AT graph. And then for rocket B, for velocity, we can, since the acceleration is constant, it doesn't have any variable, we can use the kinematic formula V is equals to V sub 0 plus AT. So since it starts from rest, your V initial is 0. Therefore, V is equals to AT, and your V is equals to 20 T. This is your velocity at T is equals to 0 to T is equals to 12. Then we need to find the constant speed at T is equals to 12. Therefore, just substitute the value of T with the 12. We have V is equals to 12 times 20. We have 12 times 20, 240. We have 240 meter per second for T, 12 to T is equals to 20. Then, we may be able to create the VT graph. So first, 20 for V is equals to 20t. We can use your table function here, 20x, and then starts from 0 and at 12. You can see that it has a constant growth of 20 per second. There. So therefore, we can conclude that its graph is just a diagonal line, which means the graph for our first part is this, and then this is for 12 seconds, and then it stays constant for 20 seconds. Constant, a horizontal line, constant. And then at 12 seconds, we have a speed of 240. This is meter per second, and this is second. And then that is our VT graph for our rocket A. Then we need to find its displacement. We have S. We have the formula S is equal to V sub 0 t plus AT squared. Again, we're using kinematic formula since the constant there is a constant acceleration here. Therefore, we can use these kinematic formulas. And then again, 0 is the initial velocity. And then S is equals to AT squared. S is equals to acceleration of 20 t squared. That is for t is equals to 0 to t is equals to 12. And then to find the displacement at t is equals to 12 to t is equals to 20, we can use, since there is no acceleration in this, we cannot use the kinematic formula. So let us use the other formula, which is V is equals to ds over dt. We have ds is equals to V dt. We have ds, or change of s, is equals to V. Let's say our limits here at 12 seconds. Therefore, at 12 seconds, let's compute for the displacement. At 12 seconds, s is equals to 20 times 12 squared. So I forgot there is a 1/2 in our formula. I'm so sorry. This is divided by 2. Therefore, our governing equation should be here should be 10 t squared. Therefore, our s at 12, we have 10 times 12 squared. We have 1,440 meters. We can put that in our limit. Here, 1440 to s. For v, our velocity is 240. We have 240. Oh no, sorry, it's time. That limit here is time. Therefore, the time is 12 to time. We have s minus 1440 is equals to, your v is 240 t with limits of t to 12. We can isolate the t minus 12, and then we have s is equals to 240 times t minus 12 plus 1,440 1,440, and then s here is 240 times 20 minus 12 plus 1,440. We have 3,360 meters. Now we have our two values for our ST graph. So our first equation is 10 t squared. So since it is squared, this is a graph of a parabola. Be able to use your value here, 10 x squared, 0 to 12, 0, 10, 0, and then 10, and then 40. As you can see, the rise is quite obvious that this is a parabola, or the values says that this is a parabola. You can see that the graph behaves like this. This is for 12 seconds. Size font is 1440. And then our second equation here is 240t, which again, a degree of 1 will lend us a diagonal graph, a constant trace of 240. 240x. Our equation here is 240 times x minus 12 plus 140. I have 12 to 20. There, 1440 at 12 seconds. And then it ends at 330. So the graph should be more inclined. Just like that. Your highest point here is 3360. So this is your graph for the rocket A.